Howdy! Howdy, 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 howdy. Sorry we're a bit late today. Well, we're starting a bit late. Yeah, things are looking good. Let's check that we have audio. Do we have? Okay, we've got audio. Let me just check my phone real quick. And turn up the brightness. So you may be wondering why we're on this pause screen here. Well, I assure you it is for a very good reason. Because we have just finished a world record thing. The Bad Apple 3D printing project. Okay, hold up. Cool. So, the Bad Apple 3D printing project. It's done. It is, in fact, complete. So, let's just swoop down to here, and we'll see what we're doing. Yep. Everything has been finished. Holy crap. Okay. I think we can comfortably hit the stop recording button. This has been an absolutely humongous project. Just beyond absurd. This started in July. Yes, think virus. It is done. The Bad Apple 3D printing project is done. Okay. Hello, think virus. You're new here, so it seems. Yeah. Okay. So I'm going to hit the off button and then tick on freeze. Think. Yes. It is done. Okay, so how many ticks of in-game time did it take to do this? 156,130,818. 156 million ticks. Full odds me plus. Yes. Yep, unfortunately. Oh, no. I started. Okay. And we're back. Hello? Hello? Are we back? Hello? That was weird. I hope that's not going to be a recurring problem. Because, yeah. Bad Apple, complete. Okay, good. Thank you for allowing me plus. Okay. I'm going to now save and quit to world. So now this replay file needs to be saved. So that's going to take a wee bit of time. Let's do the math here. Precise. Oh, precise. Oh, come on. Come on, OBS. Come on, don't be a jerk. Certified moment. Okay. I'm going to pause that stream on there. Anything else I can kill? Because I have a canvas thing open. What happens if I kill that? Hopefully that improves things. Oh, come on, OBS. Are we back? Hello? Hello? Come on. Come on, OBS. Quit being a jerk. Okay. We're good? Well, this is going to be very frustrating if that's the case. If that's what we're going to end up doing. Is it calculated as doing this? Anyway. I'm going to real quick do this math. So that's 22,000 hours and 29 minutes and 0 seconds. Okay. And then 2,168 hours translates to 90 days. Holy crap. Yowza. 90 days, 8 hours, 29 minutes, and 0 seconds is the in-game time that this would have taken. Now, because because we're in the latest Minecraft update, we have the ability to do tick speed, or tick rate. So it, in fact, did not take 90 days. In terms of actual time that the game was running, it's about 30 days, maybe 35. So that's good. That's very good. That is how long that this 3D printing project took to complete. Holy smokes. Okay. So with that, okay. Can we... Why is Desktop Window Manager always ramping up the memory like that? That is so weird. What the heck is taking up so much memory for just managing a desktop window? Okay. So anyways, let's see. So my computer, I'm going to do the same kind of thing we did last week in the live stream, which was running 2 instances of Minecraft simultaneously while we awaited for this replay mod thing to save its progress, because we definitely don't want to lose the replay now. So this is a joyous occasion. And now we celebrate by hopping on to the card game hub, and we shall play some games. For those of you who have a Minecraft account, please join. I'd love it if you joined and join the card game hub. Currently, our server software is Aternos, which with 3 additional RAM. I think I'll be fine. What do I have to do to get a free RAM boost? Let's see what we have to do in order to get a free RAM boost, because we can always get a RAM boost. Okay, so you can either download Metal, record a Minecraft, then record a clip. Okay. I ain't doing that. I don't know what these fools think they're up to, but I ain't doing that. Instead, we're just gonna run Aternos the normal way. Okay. And it looks like Minecraft's taking a little while to boot up. So hopefully it'll boot up before the server closes automatically. Either that, or somebody please join the server. So yeah, somebody please join the server. I would before it closes. Okay, let's minimize that window. And I guess we can keep this page open. Okay, there we go. There's the debug screen. Oh, and normally I would have music playing in the background of these live streams. However, the music takes up a lot of RAM, a lot of computer resources. So I don't want my computer to completely explode. So we're going to wait on the music until Bad Apple is done rendering. Hopefully Minecraft can boot up, and then we can have some. Then we can celebrate at the Card Game Hub. I would have brought your PC home with me. Ah. Oh well, that's all right. Okay. Okay. Almost there. Okay, well in that case, if nobody wants to join the server, then I guess we can do our standard thing, which is program the latest game that we're working on. Invalid session. You have to be kidding me. Okay, the universe is against us. I guess we're just going to do some programming. Sorry about that. So Minecraft's being a jerk. So not only is OBS being a jerk, but Minecraft is being a jerk. All I did was crash it to the point of ridiculous by trying to 3D print the Bad Apple sequence. Like, come on, it's not that big of a deal. Why you gotta do me like that? Okay, here be dragons. Create a backup and load. So, what have we been working on? The most recent work has been on the board game Risk, which has proven to be one of the most complicated things that I've ever worked on. Both programs are fighting to see who's the biggest jerk. Yep, that sounds about right. Okay. Oh, and just FYI, both of you in the chat, but I assume those are the two viewers here. So this is on this live stream. I ask that you please don't use my real name. Okay, just refer to me as Java or Javamonk. Y'all know me in real life, so that's the way it is. It's a public live stream, and I don't want to get murdered. So please don't use my real name. Okay? Cool. And if you do, I'll just delete your message. But yeah, keep that in mind. Okay, so what have we been working on with Risk? So recently let's see. So most recently, we created the system that handles the attack cycle, which is essentially it's a thing that lets you, first you choose where you're attacking from, and then you choose where you're attacking to. And then it does the whole rolling the dice thing. It does the whole thing where if you decide to quit, then it counts as a loss. It also handles the special cards that change things up. So let's think. At this point, the things that are really missing from this game thus far is we need the systems that can, let's see. Add move, fine. So what we need is basically the systems that actually kind of link it together and create an actual game. So this is where we get to the part of rotating the turn. So we got to rotate the turn. We need to, at the start of the turn, do stuff or enable stuff to be done. Oh, another big thing that we did in the last live stream, we made it so that you can, okay, I see my mic is going red a little. So another thing we did in the last live stream is we made it so you can move armies back and forth. Or when you're given bonus armies at the end or the beginning of the round, then you can essentially be given that reward, and then you can place it wherever you want. So I think the next step here, or one of the next steps would be to figure out how to do troop movement. Because this is a thing that's going to be tricky. Let's see. Yeah. See, troop movement is going to be weird because it's essentially going to have to be like a permanent thing. Well, actually, no. If we're doing troop movement, you can move literally whatever armies you want, literally anywhere else. So just trying to think through that. Yeah, troop movement, you don't have to restrict anything to anything else. It's the bonus armies that do that, where you have to ensure that you don't remove armies that were already placed, and you can only ever add stuff to the countries. So for troop movement, you can move literally whoever you want, wherever you want, as long as the countries are connected. Or as long as there is a path between one country and another. Okay, so for those of you who don't know the board game Risk, what I just said is going to make absolutely zero sense. This is Risk. This is the board game Risk. It's played on a world map like this. And yeah, so troop movement. So just to explain what troop movement is. Troop movement is where, let's say you have like four army people there. You have 2 here, and you have 1 here, and say you have 5 here. Okay, so this is a bad demonstration. 3, 4, 5. So there's 5 guys there, 1 there, 2 here, and 4 here, right? So what troop movement lets you do is you can essentially, as long as you keep 1 person in each country, these are all connected to each other. So what you can do is you can go over here, leave 1 there, and add 2 back over here, and then add 1 over here. So yeah, this is a thing that you can do in the board game Risk. You do this at the end of your turn. So, and that's essentially how you do, like, that's essentially how you fortify your position. So let's go into, okay, so the attack cycles are basically done. In fact, that's done. So at this point, we've done the attack cycles. So now, yeah. So we need to do troop movement. Okay. So this is going to be a somewhat complicated system. So let's see. How do we do troop movement? So what are the elements? Let's think about what the components are to do a successful troop movement. First, you need to be able to go, hey, I choose this country to pull things from. And then you need to choose a target country, and that target country must be connected to the one that you started from. So in this example where we're pulling stuff from East Africa here, then if you have, let's say you have guys over here, and you have guys over here, and you have guys over here, and you also happen to have guys over here, then you can do troop movement. You can move troops between these 4 countries because they're connected to each other, but this country is disconnected from those 4 here, from those 4 over there. However, if you had guys spread out over here, then you can troop move between these 3 countries. But you can't troop move between this and these 4 here because they are disconnected from each other. So you have, in order to do a successful troop movement, you have to own all the countries. Just bit the inside of my lip. You have to own all the countries in between where you want to go. So the question, of course, is so the question is, do you want to have do we want to have a system where you pick a starting country and then you can only select the ones that you own or that are connected? So you can only select the valid ones. Or do we have it where you can select any 2 countries, and if they're not connected to each other, it'll just yell at you? So here's the thought. So here's the pros and cons of each option. If we go with option A, which is you can only select valid. So the pros with that is, well, it's easier for me. You can only choose valid countries to go to, and so you'll only be able to troop move between valid countries. So the cons with that is that if for whatever reason you choose, let's say you choose to troop move from something where your country is completely isolated, like say these 2 are owned by somebody else, you don't own those countries, then that's going to cause a problem because, you are then not able to select anything at all. And we would have to somehow detect that. Well, if we do that, then it can still yell at you. However, let's say the player's kind of dumb, and let's say they want to try to troop move from here to here anyway. Then they're gonna try to punch here to select a country and be very confused as to why they can't select it. So for that reason alone, I think this is a bad idea. Okay, so I just talked myself out of this idea. So that means we're going with option 2, which means if for whatever reason you choose to troop move between 2 countries that you're not supposed to be able to, then it'll detect that, and it will just yell at you and then cancel your selection. So yeah, it'll yell at you and cancel your selection. I think that is the most sane way to do this. Right. So, placing troop additions or reinforcements. Okay, so we need a special block here. This is amethyst equals active troop movement. You are actively trying to do troop movement. So from here, we need to do some graph theory. We need to do some graph stuff to detect which countries are connected and which countries are connected to each other. And that way we can yell at the player if the two countries that are selected are not connected. Yeah. And actually, this is ideal. This is actually a better plan because, yes, I know you love graph theory. Let's see. Yeah, this is also a good plan because so what we're going to be trying to do is a depth-first search. This is something that I had to do already for the board game Ticket to Ride. So we're essentially going to be copy-pasting that same code. In fact, a lot of what we're going to be doing is going to be a lot of copy-pasting. But we are going to have to modify things just for the sake of the difference between Ticket to Ride and Risk. Well, I wouldn't say the difference. There's many, many differences between those two games. But in terms of what we're trying to do with Ticket to Ride, for those of you who are unfamiliar, Ticket to Ride is a game where you place trains to connect cities, and those train lines have specific requirements. So the difference is that the train lines were already on the map, and they're permanently on the map. They're just always there. So the depth-first search that we could do, we could just check all the train lines. The difference here with Risk and Castle Risk is that the thing is, this is a bit like having a Ticket to Ride map, except where the map only has the cities, because, stop, thank you. It's a bit like having a map where you only have cities, like a Ticket to Ride map with only cities, because, the lines are not obvious, and they're not like a permanent feature of the map. So for the sake of, just to demonstrate, if I activate the map risk, generate connections, generate countries. You can see here, so these little dots here are exactly where the countries are going to be, but there's no feature of the drawn-in feature of the map that connects those countries together. I have to do that myself with code. So let's see how to do this. Well, lucky for us, in each of these ZMap Risk and ZMap Castle Risk folders, we have this handy little, we have a function to generate the countries, and we also have a function to generate the connections. So this will summon a whole bunch of armor stands. And each of those armor stands are going to have a special connection ID. And that connection ID is exactly what's going to let us, well, connect the dots, essentially. Literally connect the dots. So we talked about this in the last live stream, but we're gonna talk about this a little bit more. The math involved. So this connection ID, why is this done the way it is? So for example, this Eastern Australia is country 1 and Western Australia is country 2. So if I want to indicate that there's a connection between them, then the connection ID is going to be 001002. Now, why did I do that? Because in Minecraft, with Minecraft coding, basically every variable is global. You have access to basically every single number that you can store anywhere across the entire Minecraft world, which on the one hand is nice. On the other hand, it's not. It means that you could optionally... Okay, so really the reason is I didn't feel like keeping track of two different numbers, one for the starting country, one for the ending country. So instead it's merged into one number, where, yeah, it's 001002 to connect the two countries. So that's the connection ID. So now, how does the depth first search work? So I need to create a new folder here. We're going to do the troop movement. So let's have a think about this. So we can open this in a new tab, open up a ticket to ride, and we can go through the code. We're going to copy paste the code and then see what made it work. So data packs, going into ticket to ride. Oh yeah, this actually gives an overview of every single game that I have on the server. So we have 52 card pickup, apples to apples, battleship, blackjack, bridge, castle, chess, Chinese poker, code names, Connect 4, Crazy Eights, dominoes, DOS, Egyptian rat slap, floor is lava, generals, gin rummy, hearts, madness, minesweeper, mini golf, musical chairs, projective set, Scrabble, scat, spades, speed, spoons, Sudoku, Texas poker, Texas Hold'em poker, ticket to ride, Tianlen, also known as Viet Cong, trivia, as in it's like a Jeopardy trivia game, Uno, and Whist. So lots of games. It's a very big hub. And of course, the reason it's so big is because, well, this is kind of my thing. This is my baby. And I just got to keep working on it. I can't not work on it. Okay. So with Ticket to Ride, we had this system to handle tickets. So we're going to do... Oh, interesting. Okay. We have an already searched stack, and we have a search now stack. We then have an add to search stack, depth first search. I'm pretty sure start check and swap cities are also involved. So we're going to copy that. And then extract tickets. What did this do? And do we need to do it ourselves? Okay, so it extracted the card, extracted a ticket card, yada, yada, yada. Okay. Right, I don't think we need to do that. What about find edges? What does find edges do? Oh. Huh? Okay, I think that's part of the depth first search process. Okay, and then handle one ticket. So this is more specific to the... okay, this is going to be important. Instead of handle one ticket, this is going to be the function to verify troop movement. Okay, and then read ticket. Do we need to do anything with this? We have ticket readers. No, we do not need to do that. Okay. Start check. Summon extraction. Do I need to do anything here? No. Okay. In that case, we now need to just update. Okay. So let's go through this code. When we go through and verify the troop movement, so I'm going to real quick do a thing. We need to replace ticket to ride with risk. Okay. So instead of, right, so we don't need to do that. We don't need to read tickets. Right. Okay. We can just start search. Oh, and we should also replace z tickets with z troop movement. Oh, hello. Thank you, mouse. Okay. I think the replacement of ticket to ride with risk is going to be much more handy. Okay. So normally this would give points if it's successful. And it will tag the player as a success if it finds that the connection is there. So we do execute unless entity at s tag equals success. Then we run tell raw at s. This is where we yell at the player saying, hey, you didn't. These two countries are not connected. The two selected countries are not connected. So that's color is going to be red, bold is going to be true. Okay. And we don't. And then if it is successful, then we say success. Oh, right, we don't have a recursive step here. Okay, so then we then run the function. So at this point, we then need to, so failure, remove the selection. So then we do tag at e, predicate equals risk in dimension, tag equals. We're going to call these troop move from and troop move to. And then remove troop move to. We also need to, okay, how does the depth first search work? Okay, so it recursively does depth first search. Adds to the search stack. Handles the multiplier. Yeah. Okay. Cool, cool. So that means this can just be the, so this basically sets off the depth first search. So we remove the selection, and this should also be the part where we do cleanup. Unless the depth first search already does cleanup. That's fair. Let's make sure of that. Uh, do, 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 do. If there's anything to search, then go search. Okay. Mm-hmm. Gotcha. And then this is, right, if your tag is success, then return 0. Okay. Yep, so it just returns if it's successful, and if it's not successful, it'll go until it runs out of things to search, at which point it does that. Okay, and I just realized what I just said makes absolutely 0 sense. So let's do the cleanup first. We'll go one step at a time. This is honestly this is really the biggest problem that we've been having in this whole castle risk project. Just going one step at a time. So when it's a failure, we remove the selection. We also need to do some cleanup. So we do predicate equals risk in dimension. Already searched stack. We need to go into here. Replace ticket to ride with risk. Oh, we need to replace city with country. And cities visited. Oh, cities with countries. Okay, so we need to remove the tag of countries visited. Yeah. Tag equals countries visited. And then also remove, and you can only visit, there's only 48 countries total. So this is fine. Okay. And then push to stack. So we need to replace cities with countries, replace city with country, and then replace ticket to ride with risk. So this is pushing to a stack. Cool. And that's all country ID, which is exactly what we had. Okay, cool. Right. So that handles the pushing, and we have the summon, so that's fine. Oh, there's a whole other set. There's a whole other set of things that's done before you ever read a ticket. And I failed to consider that. Naughty. Okay. We'd do data packs. Ticket to ride. Data. Ticket to ride. Function. Okay. Z-tickets is not the only thing. So let's see. So this is at the end of the round. So this is all done at the end of the round. We do draw tickets. That's not it. Where is that? Okay, when we rotate the turn, we set off the function end round. There it is. I was just blind. Teehee. Places to Western block. And, aha, Z end round. Yep. Okay. So when we start, we activate ticket points, summon extraction, tag as loop end. Okay, fine. Then we do search tickets. Extract the ticket, handle 1, remove line of interest, and then rotate the turn. Okay, that doesn't matter. What does the end do? Right. And we gotta do some cleanup here. Extract country. Extract country. Let's make sure this is 16 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. Okay. And that does not matter. Okay. So subsequent players. So how does this work? So when we start off the next, when we actually do the searching, we have line of interest. We tag it as being a player line that is of interest, and then we activate the function extract tickets. Okay. What does search tickets do? Also extract tickets. Okay. What about first player? Nothing special. Okay. Really? Does nothing special. Where the heck does it do the where does it do the thing then? Where does it summon the different stacks? Is it in start check? Yes. Okay. Cool. Okay. Yep. That makes sense. Okay. So back to troop movement. So in this situation, so we start the check, which also does the depth first search, and then we have to do some cleanup afterwards. We then remove the selection if it's a failure, and if it's a success, then give tokens. And we can go turn and run. Okay. So then if you're successful, then we then have to do the whole setup where we give the player the tokens that they need. So min move. So what do we have as inputs for this? We need to go into zmove armies, give tokens. I should write down the inputs here. Inputs. I should just put that down up here. So the tags are min move army 1, min move army 2, min move army, and then min move army 1, min move army 2 as scoreboards. Okay. So that is, so we do that. Excuse me, min move army 2. We set them both to 1 because you have to have at least one army in each one. Set at E predicate equals risk in dimension, tag equals move army 1. Ktemp. Right. Ktemp, min move army 1, set that to 1. And then here, min move army 2, set it to 1. And then we also do, well, actually, we're automatically assuming that this is a success. So we don't actually need to do this execute if stuff. Okay, so we then do tag at E, predicate equals risk in dimension, tag equals troop move from add move army 1, and troop move 2 as min move army 2, move army 2. At which point we then run the function execute as at A, predicate equals disk in dimension, tag equals your turn, add run function risk z move armies give tokens. So those then give the tokens that lets you move armies between the two countries that you just selected. Okay. Cool. Cool. So now we need to run the depth first search. So now we go into start check. So let's go in and do the graph theory. So we start off with the function start check. So we need to make our replacements. Z troop movement. Okay. So then we then have troop move from to the stack of search now. Oh, we also need to replace rtemp with ktemp. We need to replace city with country and cities with countries. Okay. Country ID equals that. Instead of that, we're doing tag equals troop move from. Okay. And then country search 1. Yes. Okay. So in the search now stack, we need to fix this. So replace ticket divided with risk, replace city with country, and cities with countries. So the way that depth first search works is essentially you're going to have two lists. One list is going to be all the countries that you've already searched, and one list is going to be the list of countries that are left to search. So essentially what's going to happen, the basic idea is the way this works is, let's say you're at a particular country, then it's going to look at every single country that you can connect to, and if you can connect to it, and you haven't already searched that result, the country on the other side, then it will add each of those countries to the list of things to search. So it'll just keep adding stuff to the list of things to search, at which point it'll then pull the next thing off the top of the list of countries to search, and it will search from there. And it'll just keep searching over and over until eventually, in the list of countries to search, eventually there will either be the country that you are looking for, at which point you're done, you're successful, or the list of countries to search will go to 0. It'll empty out. There'll be no more countries to search, and you did not find the country that you're looking for, at which point it's a failure. So yeah, that's the idea there. So we don't need to do that. Okay. Match country ID. Cool. Right. Type equals item display. Tag equals country. Okay. So now begins. So that's the basic idea of the depth first search. And now we need to do the thing. Okay, so this does the start check. So we also need to verify the summon. So this is all good to go. We have countries to search and country search. The push, so this is moving stuff to the stack. So here we need to do replace cities with countries, replace city with country, and we have replace ticket to ride with risk. Okay. And then we need to do the same thing for the pop. So replace ticket to ride with risk, replace city with country, and replace cities with countries. Now, the reason these files are there is because this is the fun part about programming in Minecraft, which is that Minecraft has no idea what a list is. So the way that this is done is essentially we have a big stack of armor stands, which are labeled, like position 1, position 2 was country search 1, 2, 3, 4, all the way up to 48. Okay? So from there, it will then say, so whenever since we can't really, we can't just shove stuff onto a list. So the way that this works is so if you're familiar with computer science, what I created is essentially an off-brand version of a stack. So when we pop from the stack, that means pulling something right off the top of the list. Only the first element. We don't care what the other elements are. What happens there is it just removes the first element, and basically all of the armor stands then give the previous armor stand its country ID. So it'll just completely override whatever was there. So it basically does. So yeah, it goes country search 1 will now country search 2 will give its country ID to country search 1, then 3 will give to 2, 4 will give to 3, 5 will give to 4, and all the way down the chain. So from there, the push is basically the opposite. So in order to do a push, you need to first make room for it. Push only puts the thing, whatever thing you want to add to the list, it adds it only to the front, to the very top of the list. So in order to do that, it needs to go country ID 49. So 48 needs to give to 49, then 47 to 48, then 46 to 47, all the way down to giving the armor stand 3 will give it to 4, armor stand 2 will give it to 3, 1 will give it to 2, and then 1 is empty. So then whatever you're trying to input, it'll shove in that thing. So yeah, that's popping and pushing. That's the computer science stuff. And I learned how to, funny enough, I learned how to do this by programming spoons. And I only thought to do that because I was taking a computer science class at the time of making spoons. We literally were talking about stacks and queues and all that other stuff. And it's like, oh, well, that makes sense. Why not just do that? Now, this isn't a proper, I will note, this is not technically a kind of correct kind of stack. Because in order to be a correct proper stack, the amount of memory involved needs to be infinite. Because in theory, like with the stack, you can just keep adding stuff to the front and it'll keep chaining back. So it can theoretically go infinite. With this case, well, we can't really do infinite. So, I mean, I probably could. Just like anytime we pop, just remove the last armor stand, or if we push, then create a new armor stand. But that's too much work. So it's a limited case thing, and also it helps to prevent lag. So very good thing to have. And also, there's just less room for error if we have a finite amount of armor stands. Excuse me. So this, by the way, is exactly the same mechanism that I used in every single card game to do a draw pile. Essentially, whenever you draw something from the top, all the cards just shift forward. And if you need to if you're discarding a card, all the cards shift back and it's added to the discard. So this is a thing that's been in existence for a while. And in fact, it is the pushing and popping. That's exactly why the ever since doing that for spoons, before spoons came around, the card games were very, very laggy. Whereas now, no problem. Okay, and I will say there are two games where it is actually infinite, which is DOS and 5D chess with multiverse time travel. And those are infinite. So DOS has an infinite arena, and actually, in terms of the actual mini golf can handle infinite players. Madness can handle infinite players, but that's just because it doesn't keep track of IDs. Dominoes can handle infinite number of intersections. But the thing is, those sorts of infinite cases are very rare and kind of hard to work with. So I just didn't bother with Ticket to Ride and Risk. So let's see. Okay, so anyway, onwards to the depth first search. So we need to replace city with country. We need to replace cities with countries. We need to then replace Ticket to Ride with Risk. And replace the tickets with the troop movement. Okay, let's see if there's anything else that needs to be done. So this thing is going to execute as the country that we are currently at. So whatever country we're currently searching. So it'll pop from the search stack, and it will. So then if you're successful, then it'll just go back. If you haven't visited this country yet, we add this country to the list of countries that we've already visited. I also need to replace our temp with ktemp. So it'll add the current country we're at to the visited stack so that we don't visit that place again. And then if if countries visited, if you are at a country that you've already visited, then it will go back and try again. At which point, we then push this country to the already searched stack. So, yeah, and we'll just do that. Okay. So now we check if successful. So if we are currently at the country that we need to be at, so we need to replace this with troop move 2. Troop move 2. And actually we need to do return run. So if we're currently at the country that we were trying to go to in the first place, then we stop at this point and tag it as successful. So it'll go, yay us. So then it'll extract country 1 and extract country 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So at this point, we are not successful, and we have not visited this city before, or this country before. So now we extract our thing. So we have a multiplier. We need to extract the ID. This actually makes things interesting. So now we need to run function. Oh yeah, this is gonna be fun. Right. So we did this to verify the attack. How did we do it? Before phase 1, validate attack. Okay. Cool. So then we need to do, so we need to look up the connection database. Oop, okay. So we need to copy from here and copy over to here. Okay, so we generate the whole list of connections for that particular map. So from here, we then do, let's see. In fact, I think we can just copy this. I'm pretty sure this basically does the same thing. So, except we need to replace this with extract country 1 and extract country 2. Nope, show country 1. We go replace, 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 replace. And then replace country 2 with extract country 2. So we need to go boom, boop, boop, boop. Okay, so let's think about what this does. And think about, do we need this line of interest stuff anymore? So this generates all the connections, the list of all the connections. And then for each one, it'll grab extract country 1, set it to the country ID, and extract country 2, at which point it'll either divide by 1,000 or do a modulus by 1,000. So that, which is a modulus is a divide by that thing and return the remainder. This is why we have the ID system have like 001, 002, because it basically separates those by thousands. So if you divide by 1,000, Minecraft can't handle decimals. So if you divide by 1,000, it'll remove the second thing and keep the 001 part. And if you do a modulus by 1,000, it'll ignore the first part. So that's how you get one ID to generate two different numbers. This trick is also used in multiple other games, such as Chinese poker, where essentially Chinese poker as well as Texas Hold'em poker, you have a quick and efficient way to rank flushes, because flushes can basically be done with any cards. So with any 5 cards of the same suit. So essentially what's done there is I translate the cards to numbers and then write the flush in base 14, because there's base 13, because there's 13 cards. So just rank all the cards in order of number, and then write them in base 13, which separates them out in terms of powers of 13, and that basically separates things. Very handy. Okay, so we do for each connection, unless your extract country 1 matches country ID, or unless extract country 2 matches country ID, then kill at S. Okay, good. Good. Okay, so then we need to do extract country 1 before extract country 2. So from there, we then need to find edges. Okay, so let's minimize the sticker thread. So then from here, we need to find edges. So then if extract city, okay, extract country2 equals, let's just make this replacement, and then replace ticket to ride with risk, z troop movement, swap countries. Yep. Okay, and that's ktemp. Okay, and then for swap cities, we replace swap cities with swap countries. And then we replace city with country. We replace our temp with ktemp. Okay. So this is just for ranking purposes. This is purely just so the extract country 1 is before extract country 2. Just for the sake, it's just to help with the setup here. Oh, and we also need to do find edges. Let's see, what else does this do? Oh, just does that. Okay. Right. So from here, it finds the edges, and then we need to add all the connected countries to the stack to search, unless it's already there. So right, so we also need to limit the, it looks like we're also going to need to do something to make sure this is the player, make sure it's owned by that particular player. So how to do that? We can just kill the connection. I think that's the best way to do this. So let's see. Execute as at e predicate equals risk in dimension, tag equals connection, run oh, this is going to be so weird. It's going to make things complicated. Okay. So we need to ensure that it'll only look for we need to make sure it'll only look for the player who actually owns that particular country. That's bad. Ooh, 51%. Yay. Okay. So that means we need to do verify player, that MC function. And I think this should be done after we swap edges. So then we do execute, well, we just run the function risk z troop movement slash verify player. Okay. And then what this function is going to do, why is my light flickering? That's weird. Anyway, we do scoreboard players operation ktemp country ID equal. Is it just me or is that light flickering? It only does it when it's in the peripheral vision like this. That's very strange. Anyways, so we set the country ID equal to at s extract country 1. Well, actually, extract country 2, because this is the country that we're going. This is the country that we're trying to reach here. So now we do. So then we do execute if entity at a predicate equals risk in dimension. Nope. Dimension tag equals your turn. Tag equals player 1. If your tag is player 1, and unless entity at e predicate equals risk in dimension type equals item display tag equals country predicate equals risk match country ID tag equals player 1. Then run kill at s. So what does this do? Well, what I hope to do. So if you are player 1 and the country which you are trying to reach is not owned by player 1, then kill the connection. It's not a valid connection. So that's the hope.